it should be from 2 to 2.5 or 2 to 3, in between that, or even more precisely you can say one, more than 1 but not more than 3, not more than 3. Okay, so just take sample readings, and as I said, do as directed. That will easily direct you and lead you to a correct readings. No need to worry about, just do as the procedure is advised. But more focus here how to take readings. Then you have to take mass of Fa4, mass of Fa4 used in grams. How? You have to subtract it. When we subtract, let me do subtraction. So this will give you 1.3 here, 1.30. okay, so this should be the mass of Fa4, the difference of these two readings, the difference of these empty plus the Fa4. When we subtract, we get the mass of Fa4. Now start heating. So we can say mass of crucible, or even straightforward you can say mass after first heating, but I'm writing in detail mass of crucible plus lid plus Fa5. Why I'm writing Fa5 instead of Fa4? Because we know that when we heat any metal carbonate, it will change into its oxide and releases carbon dioxide, as the equation is given, okay, in the start of the question. So now Fa4 turned into its oxide, the carbonate changes into its oxide, that's why I'm writing it is Fa5. okay, so we can say after first heating the mass goes little decrease, and I can say it is 17.57 roughly. okay, so you have to do it your own calculation according to your weighings. Then I said the procedure exactly said we have to cool it down and take the readings. okay, so if you can see that there is change in mass, so you have to heat it for the third time. So it I've missed one thing, mass of crucible plus lid plus Fa5 after first heating, after first heating. And now here you can say crucible plus lid plus Fa5 after second heating, after second heating. So let I say there is decrease, little decrease, so I can say 17.53. so little decrease, so that's why there is change. So I'm going to write and take another reading as well. So this is called as heating till constant mass, heating till constant mass. This makes sure that the heating is complete, the decomposition is complete, so you must have to do this additional further heating. So mass of crucible plus lid plus Fa5 after third heating, after third heating in grams. So now I'm going to write exactly same mass. This shows that heating is complete. When all of the heating is complete, now you have to take two further readings, which is the mass of Fa5 and the mass loss. okay, so by subtracting this value with this value, understood? So when you subtract this value, you will get the mass of Fa4 and also the mass of when subtracting this and this, you will get the loss of mass as well. So two more readings that will show, that will give you mass of Fa5. How? Just subtract 18.15 with 17.53 and you will get the answer 0.62 grams. And then, but please write this in the table. okay, write these values in the table, make this table. okay, then finally mass loss, or even you can say mass of carbon dioxide, okay, as this is the only thing which is releasing during the experiment. Now how? By subtracting 0.62 from 1.30, which was the original mass of the Fa4. So when you do this, you will get the answer 1.30 minus 0.62, and we will get 0.68 grams. But these two values should be in the table, okay. So this is the table. You have to make this table very nice and clean, not according to me. This is a very rough situation, so please make this very clear, okay. Use your scale, ruler, and then try to write it down properly. But there must be at least 5 readings. There must be at least 5 readings. You can see the 5 points, okay. And you have to take care that all of the reading must follow the same decimal point pattern. Like here I followed 2 decimal point pattern. You must have to follow the same pattern. Then calculate. Going for the calculation, calculate the amount in moles of carbon dioxide. These are very simple steps. Now how? We know that by dividing the mass of the mass loss or mass of the carbon dioxide, which we calculated in the last, divided by the molar mass of carbon dioxide, which is 44, we will get the answer. And I'm going to divide it. So 0.68 divided by 44, which is the molecular mass. So the answer we got 0.015. I'm rounding it off 5, but I will use all of the values on my calculator, okay, and I'm not going to round off the values on my calculator. So I'm going to continue this value, but complete value that is obtained from here, okay. So keep that in mind. This will give you more accurate results. Then he says calculate the relative formula mass of the metal carbonate. For this purpose, I'm going to make the ratio whenever the carbon dioxide gas is released, and we must have to use 1 mole of the metal carbonate. You can use this ratio from the above equation that is given in the start of the reaction. So ratio is 1:1. So it says that if the moles are 0.0155, then the same moles we will have of the metal carbonate, 0.0155. So keep that in mind. Now we use the formula moles is equal to mass over mr, and as we are going to find mr, so we are going to divide the mass over moles. Now we have the mass of the Fa4, which was 1.30 we used, okay. You can take values from the table, and then the moles we calculated here are 0.0155, but I recommend use your complete value from the calculator, okay. Then when you divide this, so I use the answer I already have in my calculator, and now dividing 1.30 by the answer I have in the previous part, so this will give us 84 point, the value is 84.118. Understood? Then from your results deduce the identity of M. So as we know the method of calculating the MR of M carbonate, okay, it should be done. We have one metal which is unknown, plus we have one carbon, and the atomic mass of carbon is 12, plus 3 atoms of oxygen, and the atomic mass of oxygen is 16, and we calculated the MR in the previous part, which is 84.118. So now M plus, when I add these values, I got 60. So to find M, what we are going to do, 60 is going to the other side and is subtracted, 84.118 minus 60, and finally this will give us 24.118. So it is approximately 24.3. that is the atomic mass of magnesium, so we can say it is Mg magnesium. Okay, next he says that a student carries out the same procedure using the same mass of solid. However, the student uses the basic carbonate M carbonate and M hydroxide. So basic carbonate means it contains also some of the hydroxide in it, not the pure one. So then he says, when the metal hydroxide part of the basic carbonate decomposes, metal oxide and steam are produced. So there should be two types of decomposition. This part give us carbon dioxide and metal oxide, and this part give us metal oxide and steam. As you know, the atomic mass, or sorry, molecular mass of water is lesser than the molecular mass of carbon dioxide. So we can expect that this time less decrease in mass will be observed. Okay, because the mass of water releases, and if we are using the impure form, so less mass will be observed. So in this case, what examiner is demanding, he says, state how the loss of mass from the student's solid compares with the loss of mass you obtained. So from our result, student will get less mass, less loss of mass obtained. Okay, reason, as the MR of water is less than CO2. Okay, you may prove it by just going through the percentage loss, and you know that what is the percentage loss formula. Percentage loss should be of in case of magnesium, as we calculated, the metal is magnesium, so that's why I'm taking magnesium hydroxide. So in this case, you know what is the atomic molecular mass of water, which is 18. 1 mole of steam is formed as, so divided by the molecular mass of magnesium hydroxide, which is 58.3. Magnesium is 40 plus 2 oxygen atoms. Okay, so 24 plus 32 plus 2, so 58.3 into 100. So this will give us almost 30.87%. so you can see here, and then if you find the percentage loss in case of we are using magnesium carbonate, that will give us carbon dioxide, which is 44, divided by total mass of magnesium carbonate, which is 84.3 into 100, and this is the answer, approximately 52.19 or percent. So you can easily see this mass is more as compared to this. So that's why we were using the pure, that's why the mass we obtained was greater loss. But if the student repeat the experiment using basic carbonate, he will expect less mass. Understood? Next, use a spatula to transfer small quantity of your cold residue, which was Fa5, now metal oxide, and in this specific case this Fa5 now changes into magnesium oxide. So if we have magnesium oxide, add about 1 cm depth of dilute hydrochloric acid. What happened? Magnesium oxide and HCl, they react and give us magnesium chloride, which is completely dissolved, give us an aqueous solution plus water. So no change, just we can say this is a white solid and it will dissolve. So he says record your observation. So we can say white solid dissolve to produce colorless solution. In some cases, if complete decomposition is not taken place, then you may expect what? Some of the release of carbon dioxide. So you can say effervescence or bubbles of the gas, but it may vary. Okay, if your heat is not complete, then you may expect that. And in that case, you may not obtain the correct, or you may not get the correct idea of the metal as well in previous calculations. So be very cautious while heating. Okay, then state whether or not the thermal decomposition M carbonate is complete. As I said, no release of the carbon dioxide we will observe, so that will confirm the heat was complete. Okay, decomposition was complete. Decomposition complete. Understood? Why? As no gas or no bubbles of the gas observed. No gas observed. So this could be the possible reason. Okay, proceeding. So this is the end of the question. So we done. And if you have any question, any query, you may ask. But as I said, in your practical exam, try not to worry about, just do as directed and make your paper, make your practical work simple. Understood? Okay, take care, and I will try to post the next question inshallah soon. Take care, and